Hello, this will be the second tutorial for ship design. In the first tutorial, we talked about MAXSURF stability, the orange one here, and now we will talk about MAXSURF resistance, which has a gray icon. So in search bar, we type resistance, so we have MAXSURF resistance here. Now it's open. We will proceed as we did in stability, and we can choose the model by inserting a design here. Open design, and we choose the same model we used previously. So we have our model here. You can see it, and we have four windows: the curves area, the graph, the results, and the data. The data show ship data like the length, the beam, the draft, the displayed volume, the weighted area, and so on. Some might need manual input, but here everything is okay. You can just review them, and if something is not correct, you can change it manually. So to start the analysis, we go to analysis and we need to check all these three. First, the method. As we talked earlier about resistance and propulsion, we said that there is no analytical method to calculate ship resistance. And the most used method is the model testing. But model testing is very expensive and is difficult to uh, obtain at early design stage because you don't have the exact model of the ship, and you can change the model at any stage of the design. So it's not economically wise to make a model for each change you make. So it's easier to use approximate method. So all these methods listed here are approximate method, are not very accurate as model testing, but they are accurate enough at early design stage. So for most cargo ships, we have the Holtrop, Compton, Fung, and Van Noort Mersen. But the ships that we will work with, Holtrop is the most convenient method for merchant ships like tankers, bulk carriers. Some of these methods might not work with all these types, but for regular types like general cargo, container, LNG carrier, bulk carrier, and tanker, Holtrop is very convenient. Then click OK. Second step, we select the speed. By default, speed here is 0 to 20 knot. We can change it, but I think that 0 to 20 is very convenient. I can change this for 25 or 30, but 20 is okay. Third, we choose the efficiency. As we talked that there is a relationship between the propulsion power and the brake power, and there is multiple efficiencies, and the overall efficiency is nearly 50 to 60%. So here I can choose 60%. So the power here is not the effective, but the brake power. So if I wanted to obtain the effective power, I leave this 100. If I wanted to get the brake power, I can change this to 60, which is an average value. I'm not sure it's 60. Dependent on various multiple resistance and various other parameters, but 60 is okay. We don't have to run the analysis. The analysis is already, the results are already shown. So we go to results window and we can see here the speed from 0 to 20 knot, and we have the Freud number at each speed. Then we have the resistance in kilonewton and the power in kilowatt. I can change these, of course, by changing the units. We can change the power to watt or horsepower, but kilowatt is okay. So we have the resistance here. If I need it, if I need to see the graph, we have the graph window like this, and we have the resistance from 0 to 20. If we clicked on the graph, it will show us the results like this. So the x and y as Holtrop, there's the speed and the force. I can change this from resistance versus speed to power versus speed, and remember this power is the brake power and not the effective. If I need the effective power, I can change the efficiency to 100 instead of 60%. This ball can show me the exact resistance at any point, like this. I can move it, just press on it. So, it might be a problem, but it's usually easy to use. We can just move this ball to any part of the curve like this. So I can move it here, and you can see the results here at any speed. You can see the exact result using Holtrop method, which is approximate method to calculate resistance. To save a resistance, you can save it from here, save data, and you can choose the file to save the data in, like this. But to open, you can't open from the icon because you will see that the icon has no software dedicated to open it. If it didn't work, you can just from file here, you can open measurement data, and you can choose the file that is HSD file, and you see that the file here has no icon. It's a problem, but it can be solved easily by just selecting the file. Instead of selecting it in the folder, you can just open the stability first and then click open measurement data. Thank you. That's it for resistance. I hope you learned something new in this tutorial.